Hi everyone. For those of you who don't know me, I'm Beth Robinson. I am the Business Development Lead for AI and Deep Learning in the UK at Arrow. I sit within the IBM team, so I support anyone and everything to do with AI, and that can be very broad ranging, but largely IBM's Power System platform and IBM's Watson offerings, and actually some of the bits that are a bit in between in the IBM Cloud. But essentially trying to build an ecosystem of influencers, of academics, of clients, of partners, of technical specialists who can deliver AI-related solutions, take them to customers. So today, we're not going to do the whole what is AI, what is machine learning, what's a graphics processor unit, because we talk about that stuff to the death. The idea of today's session is just to get people's creative juices flowing. I think the reality of the matter is IBM and the partner ecosystem as a whole host of technically skilled people who could help you build something for your customer. The problem is deciding what that is. So I'm going to talk about some customer stories today, and I'm not going to talk about what underpins it. They're all underpinned by IBM technology, whether it be hardware, software or cloud services. But hopefully these might spark some ideas and some thoughts about the kinds of things that your customers might benefit from today. So in the way of an agenda, I'm doing a bit of an intro, some bits around IBM's position in the market and some of the successes that we've had today. And then David's going to join us, and he is going to show you how to build and deploy a model in the IBM Cloud. Fingers crossed, everything works. No pressure. I think we have some Wi-Fi issues this morning, but we should be good. And then Ed is going to join us from IBM. I also have Zoe's name on there, but that's an error. It was going to be Ed and Zoe. It's now just Ed. Fear not, he's great. He's going to talk about PowerAI Vision and how they put together a very exciting use case to help the community. It's something a bit different. So some of you may have seen this study come out of IDC. It was less than, I think it was about 10 days ago, so really current. But this is the Worldwide Artificial Intelligence Share Snapshot from 2018. So the roundup of last year was IBM had the largest market share, that's 9.2%. And it's important to note this is across hardware, software, and their services capability. So it's really sort of demonstrating IBM as the end-to-end solutions provider. Obviously there's some services businesses in there, people like Accenture, but it shows the broad range of offerings that IBM have got. So the AI market overall is up by 35% to 28 billion in 2018, and that's only growing. You know, we're almost at the end of 2019 now, and that was 19% growth on the previous year. So a little bit about what the UK opportunity looks like, and the reason I crafted this, and I actually read the government's industrial strategy document of the weekend, which I can imagine I wouldn't recommend for some bedtime reading on a Saturday night. But anyway, it is quite interesting. The reason I put this together is we always hear stats about the global market, and I have so many partners who say to me today, oh, well, it's fine in the Nordics because they're all doing smart cities, and it's fine in the US because they've got more investment. Actually, the US, the UK are the third largest market globally for investment and capital in AI, behind the US and China. We have more capital than France, Germany, and the entirety of Europe combined here in the UK. London has more AI startup companies than any other capital city in Europe. So don't tell me that the opportunity is not here and it's not now. So there was 804 million invested in AI businesses in the first half of this year alone. That is colossal. Added to that, so in this industrial strategy, now this is really interesting, there were 4 grand challenges outlined. This is a 2017 document for the UK over the next 5 years. And number 1 of 4 was putting the UK at the forefront of AI and the adoption of AI in businesses today, followed by clean growth and net zero carbon emissions, followed by more agile mobility, so accelerating things like driverless cars, modern day logistics, delivery services, followed by caring for an ageing population. I'd actually argue that AI could help with the following 3. It was 1 of 4. And also it's estimated that it will contribute 232 billion to the UK economy by 2030. And that is what this looks like for the UK. Now, I mean, if you just look at the England figures alone, it's set to make up 10% of our GDP. This is revolutionary for our economy, Brexit prevailing and all that. I mean, it won't come as a shock to anybody that it looks like it's quite heavily weighted towards England. I mean, we obviously have a technology services and financial services hub in London, but we are seeing innovation hubs develop in Glasgow, in Dublin, in Cardiff. So there are ecosystems of people coming together, and we're seeing them slowly catching up. So where is the potential for AI and automation? So I hope I've gauged the audience correctly. Most of the presentations I see around AI are really healthcare heavy. And I have partners approaching me consistently to say, well, I don't sell to the NHS, or I don't sell to university college hospitals. So what can I do? Why is it always about curing cancer or detecting tumours or looking for early onset dementia? How is this being adopted in commercial and industrial business today? The reason why we have so much fuss around healthcare, in my opinion, is because they are research-driven organisations. So they have funding coming from the EU, again, Brexit prevailing, but they have funding coming from the EU to do things like drug discovery and cancer research, and they are heavily investing in those areas because they impact us so largely. So we see big spend in pharmaceuticals, in life sciences, in higher education, and in university hospitals. But moving away from that, if you look at this graphic on the right-hand side, it talks about the largest percentage of tasks that have high automation potential are actually things like document recording. I mean, how many organisations record information in physical documents? Most of them today. The same with handling and moving objects. These are so broad, so let's move away. And one thing I thought was really important to highlight was the bar in the middle about assisting and caring for others. They are the tasks that have the lowest automation potential. So although we talk about healthcare, and we talk about the NHS, and we talk about caring for the elderly, actually it's going to be the tasks that have emotion and the human element that are the hardest to automate. It's going to be the processes. So we talk about the risk of low-skilled workers are the highest at risk. You know, those in hospitality, those in caring for the elderly or for the disabled. Actually, I'd argue they are the hardest to automate. It's really, we're going to be going after the stockbrokers' jobs. You know, if anybody needs to worry, it's the people who are doing tasks that are methodical, that are repetitive, and that can be replaced by a machine. So just something to think about. A couple of use cases. Like I said, I've tried to move away from healthcare, and I tried to find some really sort of left field ones that might get people thinking. So if you have any ideas, please approach me after the session, or one of the guys, David or Ed, or throughout the day. The art of the possible is so broad. So this was really cool, in my opinion. This is a university in New York. When I say it's a university use case, it's not in the traditional research sense that we've seen some of the, the big revenue deals come out of IBM today. So this is a virtual labs that's helping students to learn Mandarin. One of the biggest inhibitors to language study is the expense and the time taken to travel. So if you are relied upon to care for ill members of family, or you aren't from a high-earning background and you can't afford to take a gap year or a year out, then actually this is really helpful. So they're trying to democratise access to language, and what they've done is they've built virtual labs in which a student can approach a scene like a market, and it'll be, you play along and it will detect that you are there communicating with these people, virtual individuals, in the market. And what will happen is, for example, someone could try to barter with you at a stand. you can actually pause and you can think about the tense and the context and the verbs and the nouns you're going to use in your response, and you can confer with classmates or a teacher. Then you can respond, and in real time it uses natural language processing to respond back based on the accuracy of your language and your tone and your tenses, that kind of thing. So it helps students get really hands-on and experience these real-life scenarios without actually travelling. I just thought that was really cool. And the technologies that underpin that, again, no IBM products, these are functionalities and tooling, is natural language processing and translation, which is used across the board, as we know. Another one that uses NLP is, there's a company called DeepZen that are working with IBM. And I also found this really interesting. I didn't know anything about this. Apparently, the demand for spoken word audiobooks is unprecedented and underserved at the moment. It takes 4 months to take an audiobook to market, so that's 4 months in the studio. That's not sourcing a suitable actor or sorting multiple voice actors. And what this solution does is it actually doesn't just read text and read it back in like your sat-nav kind of monotonous voice. It actually turns text into human-like speech, and it includes emotion. And this can be done in a matter of days, as opposed to the normal 6 months, and the cost associated with paying an actor's daily rate and hiring studio facilities. This one was another cool one. I've not actually seen anything like this before, but actually, if you look at the base level technologies, it is just traditional object identification and analysis of images. But actually, the Gemological Institute in the US, so they're the founder of the diamond grading system as it stands today, so how we grade engagement rings and how many people must source diamonds from somewhere, and actually the human eye can't detect the veracity of those products. Is it the quality that you paid for? And obviously there are only a select number of specialists in the US alone. So what this solution built on IBM technology allows you to do is use a mobile device to identify the unique makeup of that diamond, and you can consult the customer on the quality of that product that they brought to your jewellers and say yes, no, whether it is or isn't what they paid for. Now, I've put a little bar here about other applications. So if you think about it, you could analyse water quality, in third world countries. You could look to identify counterfeits, money, financials. You could look to identify the qualities of medicine, particularly new medicines. Are they safe? Are they imported? Motor oils, cooking oils, DNA sequences, bacteria. That is so broad-ranging, and all it is object identification. And as Ed's going to show you, IBM have got some really cool tools around that as well. This one is one of my personal favourites. Still blows my mind. Traditional machine learning. So this is an example of a customer that had lots of data but didn't know what to do with it. And this is why I try to hammer home to people. The customer doesn't need to know where they're going to use AI. They just need to know that they have a lot of data and they'd like to gain some insights from it. So Transport for London approached one of our partners and said, we have so much data, we just don't know what to do with it. We want to add more insights to our customers. And the partner said to them, well, what data do you have? Give us some examples. And they said, well, one of those data points is we have 14,000 induction loops under the tarmac in and around central London. They ping up 4 times a second, and it'll be a 0 if there's no car above it, and a 1 if there is a car above it. So we know where traffic is at a given point, in fact 4 times a second. And they said, right, well, we can take that data if you give us a sample, and we'll build you a model that shows and can predict where the traffic build-ups will be, including anomalies like congestion or a cyclist accident or something, in and around London at any junction up to 7 days in advance at any hour in the day. And it's absolutely amazing. And that's just simple time series analysis. Where is the traffic and when? And where is the traffic in 7 days' time? So again, a simple example of a customer that said, we have heaps of data, we don't know what to do with it, you show some insight, because that's the partner's value. Other applications of that could be route optimization. So for emergency services, where is the fastest route to get to somebody in need? Or logistics companies, Hermes, for example, who seem to just spend their time driving up and down the country, and taking the most bizarre routes to get to clients. How can we optimize those routes? Companies like Deliveroo, Uber Eats and the like. And last but not least, IBM love talking about Wimbledon. It is really cool, they do loads of good stuff, but this is quite a diverse example that I think has got really broad-ranging sort of applications. So again, talking about masses of data, Wimbledon have huge amounts of data, video data, that's sifted through by their video editing team and curated to make highlight videos. Now that's great, but it's a very manual task and it can take days. So what IBM worked with Wimbledon to do was train a model on previous match video data to recognise two simple things: cheering action from the audience and players' reaction, positive reaction from the players. And what it can do is auto-create a 2-minute highlight video of any given match that's available 5 minutes after the game. A highlight video that they can pump out onto social channels and put on live news streams. Now, I guess other applications of this would be, really broadly speaking, media and entertainment companies who rack up millions of hours worth of video data for tagging, for things like Netflix. Have you ever been watching a film and you've fallen asleep or something, and you don't know how many minutes in you finished watching, but you remember it was a scene in a desert? You could search cactus or desert and it could take you back to all the parts in that film with scenes in that particular setting. That kind of thing. Invaluable insights to the customer. So that's all from me today. Hopefully those customer stories, I've not talked about hardware, I've not talked about software, I've not talked about IBM's cloud services. They have end-to-end. If you want this, as Dave's going to take you through, if you have your own edge devices, if you have servers in a data center, if you have mobile devices, if you have a cloud-first strategy, IBM has something for you, and we've got so many experts who can build this stuff. Just bring us your customers, they can tell us what data we've got, and they've got, and we can consult, and we can start today. Right, David.
Okay.
Do you want to?
I haven't got a mic on, mate.
Sure.
Got me a mic? Okay. Right, sorry chaps. There we go. Right, give me 1 second. So, I've decided to take my life into my own hands, and as they say, never work with children, animals, or live demonstrations. So I decided to, I've got no children here, no animals, so I've decided to go with a live demonstration. So what I'm going to try and showcase to you today, when I say try, going to do it, is actually how you do my first prediction, which was how you actually use the latest driverless, autonomous AI systems to actually build in real time in the next, hopefully about 15 minutes, from zero to making and inferring real value, real business value. Okay, so this is the IBM Watson Studio platform. This is what we call a Jupyter notebook. So essentially it's just a data science place where we can run code, but also make lots of notes. Because, as data scientists, we like to make a lot of notes. My background is I'm a software engineer by trade, but obviously I run our AI and data intelligence business. Just to give you some context, that is worth to Arrow, well, by the end of this year, my business will be worth around and about $980 million. So that's how much business we're doing today in data and AI in Arrow with our partners globally. So it's a big, big chunk of business to Arrow, very important growth strategy. And I'm hoping to take you through today how you guys can start to actually do it with reasonably low understanding of actually what you're doing. So first and foremost, we're going to build a predictive model end-to-end. But this predictive model is fundamentally going to pivot around a business problem. So, Catherine, head of business development at Metropole Bank, is working on her team's next incentive. So how are they going to essentially retain customers? She's been tasked with increasing the retention rate of their customers. She has funding to offer discounted products, but only to a very limited number of at-risk customers. What does she do? Well, text is tiny, so I'll just read it out. So Matt, an Arrow partner, knows his customer well and understands the type of data that they have, so they have some really strong customer churn information. So basically, Metro Bank have a customer, they have a Salesforce, for example. They know about that customer, and more importantly, they understand whether or not that customer has left in the last 6 months or not. So the business workflow is business wants to target customers with an incentive to better retain them. They want to predict the likelihood that customer, the specific customer, will leave in the next 6 months, and then target those customers with an incentive to proactively retain them. Right? So this is a business problem. This has nothing to do with data, nothing to do with AI, but this is how we're going to solve. We're going to have basically give superpower to Catherine's team to be able to understand and infer when a customer might leave or not. So, first thing we're going to do, or first thing, Matt has he's the chap from the partner. And more importantly, one of the things it says here is Matt's not a data scientist. He understands data. He's a bit of an analyst. He kind of understands the possible value, but he's not a data scientist. He doesn't know about models or algorithms. He just knows that this might be valuable. So he's going to run an experiment. So the first thing he's doing is going to import the data. So he imports the data, and there it is. So we've got credit score, the geography, the gender of the particular customer, the age, how long they spent at the bank, their current balance, the number of products they have. So have they got credit cards and savings accounts or checkings accounts or whatever? Do they have a credit card? Are they an active member? So in the last 6 months, have they put money in the account? What their estimated salary is, and have they exited? This is historic data, right? So next thing we do is we basically run to understand the balance of the data. So this is the balance of essentially the output of the balance of data points in our data. So we have what we call a massively imbalanced minority class. So essentially what that means is we have very little information, or we have 1/4 the amount of information about the people who exited the bank as the people who were in the bank or stayed in the bank. This is quite common when you're doing fraud detection type analysis and you want to try and predict whether a transaction is fraudulent or an attack's happening. The majority of your data will be the transaction isn't fraudulent. And actually, you'll have a very small proportion of your data that actually is fraudulent data. But if you went to go and try and train a model using what we call an imbalanced data set, you would have a really big problem because the model would what we call overfit to the majority class. It's called the accuracy paradox. It would look really accurate, but it's actually really inaccurate. So we're going to employ a quite standard data engineering method called synthetic minority oversampling, which basically means we're going to make up a load of new data based on the existing data we have for the minority class, so for the people that left. So we're going to run that, and that essentially then gives us a nice balanced data set. So we've got pretty much 50-50 examples of people that left and people that stayed. Now I'm rushing through this at 1,000 miles an hour, but you don't need to worry too much about this piece. Okay, we can help you do this piece. It's built into the IBM Cloud. You literally just point your data and say, give me more of this particular class of data. It goes away and it generates basically very real looking fake data, if that makes sense. Right, so our data is ready to go. It's now time to actually run our experiment and to actually train our classifier that's going to tell us whether or not a customer is likely to leave in the next 6 months. So we go to our Watson Studio dashboard. From here we can run everything we need to run. So I'm just going to copy and paste that name there. Right, so we are going to run a new auto AI experiment. Okay, so this is proper driverless AI. Okay, so we click on that button based on the speed of our internet. Here we go. So we're going to give it a nice name. So I'm going to paste that name. I'm going to call it version 2. Okay, this bit is basically the size of the computing backend that you're giving the task to run on, and it determines the cost of running this activity. The more compute you give it, the quicker the task will run. The less compute you give it, the longer it will run, but the less it will cost. Things like that. So we create this auto AI experiment. Right, next we need to do is we need to select the data set that we actually want to perform the analysis on, or the training on. So Essentially, this was our initial data that had that massive imbalance. We've added a load of fake, synthetic data to it to inflate the minority class so they're balanced. And we now got 701 kilobits, so it's not big, but it's about 18,000 rows of data. We select that asset. AutoAI goes through and actually then analyzes all of the data in my data set and basically says, okay, this is all the data in that particular table. What would you like to predict? So I want to predict whether a customer has exited or not. Whether they've exited or not is a binary classification problem. So essentially they've exited, 1, they've stayed, 0. Right? Simple as that. So I'm basically going to select that. It's immediately detected that it's a binary classification problem. It's detected that the positive class, or negative class, but the thing we're trying to predict are 1s. We're trying to predict when people are going to leave. And we're going to use receiver operating characteristics, area under the curve, as an optimizer. But you don't need to worry about any of that, because all we need to do now is click Run Experiment. Okay, so the next thing this is going to do is actually start. Well, that's not great. 1 second. Right, this is why live demos, yeah, this is Matt Dedman's account, so what can I say? Yeah, 1 second. It's all right, I'm going to put more on Matt's card. All right, so now you're really going to see us under the cosh and do something we've not done before. Flying by the proverbial seat of our pants here. All right, so let's just upgrade, bung another one of those on. I think that'll do. Save. Right. Yes, why not? It's Matt's credit card. It really actually is Matt's account, so he's the one that's going to see the bill. All right, next steps. Right, so I'm assuming I can just come back into here, close that. Right. Run experiment. Boom, worked. Good stuff. That is how simple the cloud is, by the way. So what's going on here? So essentially the first thing it's going to do is read in our data set. So the data set that we've told it that we want to do training on. The next thing it's going to do is it's going to split the data set into training and testing data. So it takes about 20% of the data and holds it back. So essentially it can test against data that we've given it as to whether or not its predictions are good or not. And then it uses that to re-optimize itself into the next steps. So at the moment, it's doing the pre-processing, so normally data normalization, cleaning out any data that looks absolutely sort of erratic. Model selection. So this is a really interesting piece. So what it's doing here is essentially, I don't have to know anything about data science, right? It's doing it all for me. It's using AI at the moment to select the best possible algorithm to train my model on. So it has selected LGBM as the classifier, and it's already run the first full training session. So what it's done is it's essentially taken my data, the default settings of an LGBM classifier, which is a linear gradient boosting model, I believe. And basically, we've already got 92.5% accuracy. So we can immediately look at this pipeline, which essentially is the first run through of my training, and we can see 92% accuracy. Great, that's good news, but there's more to be seen. So great measure of sort of trained models is what they call the F beta, which is essentially a combination of loads of different statistics. If that's high, that's good. That's all you need to know. If you want to know more, there's loads of videos online. Come talk to us. We can tell you what it means. But that's at what? 85%. That's good, right? But what other information do we have? Let's try and bring this back to Catherine's problem. She wants to try and design an incentive and target customers more accurately. That's useless to her. One of the things that really is useful to her, though, is when we start to look at things like feature importance. So what we can do here is we can actually see the different elements, what the model has found basically sways the prediction one way or another. So it's seen that balance is a really important feature when we're trying to predict whether or not someone's going to leave the bank or not. estimated salary, age, credit score, number of products, tenure. These are the top 5, 6 features that the model has immediately turned around and gone, you vary these, it has a huge effect on whether or not that customer stays or leaves. Now, we obviously can't really affect balance unless we give them money. That's not really ideal. We certainly can't really change their estimated salary, can't change their age, or their credit score. But what we could feed back to Catherine from this information is actually, don't just, what was your incentive going to be? I don't know. Well, why don't you try an incentive that drives a reduced rate for a new credit card, or a really great rate on a savings account? Because from our feature importance analysis, we understand that actually the number of products a customer has is a big determiner as to whether or not they stay at the bank or not. So, I believe, as that has dropped down to number 2, we've had another completed pipeline. Yeah, so now we're up to 93.6% accuracy. At every step, by the way, so as you notice from left to right, essentially it's going through P1, which is essentially run 1. P2, it does what's called hyperparameter optimization. So it takes the defaults of that model and basically says, let's try tuning the knobs. Let's try changing some of the settings, some of the sort of hyperparameters that make up the configuration of that model. The next thing it tries to do is what's called feature engineering. So it's trying to create new features from the existing features. It might try and divide the age by something else, or it knows what it's doing. It's super clever. This is the benefit of Auto AI. I'm managing to run an entire model training sequence and look at all the results whilst presenting in front of a room of people. Right, so let's assume that we are very happy with what is currently the top ranked model. How do we actually deploy that model and utilize it and give it to Catherine to start to actually have her team figure out whether customers are going to leave or not, and then essentially use that information to target people with her incentive that we've also helped to develop, which is now going to be around inspiring customers to take on more products the bank offers. So it is as simple as this. We save the model, give the model a name. So it's got a name there, churn, predictor, whatever. Go back to our Watson Studio dashboard. So our churn predictor is still running on the IBM Cloud. It takes about an hour to complete all 4 runs because it's doing a huge amount of computational sort of understanding, trying to optimize that model, trying to do it all for me. It's doing the hard work, I don't have to. So I can get on with helping Catherine to essentially get her team using my technology. So here's the model that we've just developed. This is our current best model, the one that we looked at that had 93.6% accuracy. So we are going to deploy it. So I'm going to do the deployment, then I'm going to talk about deploying models, because I think this is one of the areas of the machine learning lifecycle. Everyone understands they need data. Everyone understands they need some magic data science in the middle to turn it into a model. But then what you do with that model is often quite a dark art. It's not. It's probably one of the simplest bits. But it's understanding the options that are available to you and where you'd use each of them, which is really important. So in this particular environment, we're in the cloud, so we're going to deploy this model as a web service. A web service basically means that we can get and make predictions by sending data over an API, a web API, from anything, from an integration, from another piece of software, from a simple web form that anyone could spin up in about 10 minutes, which is what we're going to do, and essentially start to have normal human beings that don't understand anything about data science, but understand everything to do with that customer and about the metrics that go towards keeping that customer. So we're going to quickly add a deployment. So web service, we're going to call it Jam Service. Oh, that's Jam Server, there we go. Right, so that will now initialize, and in about 30 seconds, it'll be live. But whilst we're waiting for that to come live, I'm going to scroll past all this. So essentially, what have we done so far? So we've gone through and we've done all the back-end stuff. So essentially, we've collected and anonymized the historic data. We've determined the field we want to predict, and we've pressed start. The system in the back end has then split training and testing data. It's automatically set to the best model, it's trained using the default settings, it's done hyperparameter, and it's now doing feature engineering to try and give me a better model. I don't have to know anything about that. I don't even have to know what hyperparameters are. All I know is the auto AI is working for me to give me the best possible model for my problem, to help Catherine to better predict customers' churn. I've looked at the features, and I'm really happy with the fact that it's also told me that that one of the most important things to determine whether or not a customer will stay or not is how many number of products they've got. So that's great information I can feed back immediately. As a partner, I'm offering real value and feeling pretty good about myself. But how do we go and actually deploy that model? So obviously we have deployed that model into the cloud, which is great. We can access that via integrations, we can access it via microservices, we can access it via apps on our phone, however we want to integrate. This is a simple integration task, connecting a web service that does predictions with my system. But there's other ways to deploy it as well, and there's reasons we'd want to deploy it in that way. So we can deploy it to a data center, to a dedicated, what we call inference server. An inference server, inference full stop, is basically prediction, making a good guess. All data science, all models, any of that, all it does is make a really accurate guess. And when we actually do our inference in a minute on Catherine's model that we've just deployed, you'll see that all it's doing is making a really accurate guess based on the data that we've trained it on. So when we download that model and we want to run it in a data center, it's because we want to do quite high throughput computation. We want to be able to infer lots of answers. So we deploy it onto a dedicated inference server in a data center if we wanted to do something like image recognition from CCTV. So we've done a couple of deployments recently where we've taken inference servers, put them into retail locations, and fed their CCTV imaging into the box, very high throughput, at 14 frames a second, 30 odd cameras, and essentially looked for people putting things in their pockets. So we have an AI security guard. But that was where we had to take a box. We couldn't send that up to the cloud. The latency would have been too high. So we put that in there. And then local, deploying models locally. Well, we deploy models locally when we want to be able to run that model completely in isolation, completely offline. We'd use that for autonomous machines. So self-driving cars, self-parking cars have AI models locally inside their systems. NVIDIA recently released an entire range of their Drive AGX products, which is essentially GPUs that go inside of cars, that are there to run models at the edge. So enough of the theory. That is now ready to go. It'll have been ready to go for ages. So let's view it. So this is essentially the implementation, so you can immediately download quick start code, but we don't care about this. Catherine doesn't care about this. What Catherine wants to do is start to actually predict. So let's pretend we have a customer with a credit score of 600. They're in geography 1, which is France. They are a female. They are aged 25. They've spent 2 years at the bank. They have a balance of 1,000 euros. They have 2 products. They have a credit card. They are an active member, so they are actually putting money in and utilising this account in the last 6 months. And their estimated salary is 25,000 euros. Predict. So there is a 99% chance that that person will stay at the bank. So this particular customer is absolutely not at risk. But what happens if we start to change some of the statistics? Say, instead of a 25-year-old female from France that earns and has that much in her bank account, what if it was a 55-year-old female from France? By the way, I know that the ones and zeros are females and males are from France because I designed the data in the first place, but essentially you could hide some of that complexity by just making drop-down boxes in a field and making it really, really user-friendly. But so, 55-year-old woman in France rather than a 25-year-old woman in France. We predict again. Now, there's an 81% chance she'll leave. So immediately we're offering value. If you've got customers in this state but at this age, you don't have to incentivize them because they're going to stay. There's a 99% chance based on the data we've got, that they're going to stay. But older customers, actually, there's a much more chance that they will leave, because in the past what we've seen is customers of this particular profile have left at that age bracket. And then you can modify any of these statistics, so you can change it from a man to a woman, or sorry, a woman to a man, and they stay. You can change it from, say, tenure of 2 years. Well, actually, they're staying, so try and make them leave. They've got one product, no credit card, and they are not active. So essentially, this is just like many credit cards in my pocket that I don't use anymore. Predict 99% chance they're going to leave. So immediately, we can start to give this, literally this, to Catherine, and then give her this as the output. And we can turn around and say, in the next 6 months, our system thinks there is a 99, a 54, or whatever % chance that that customer's going to stay or leave, rank the top 50 customers, and offer them an incentive based on adding more products to them. Wasn't difficult. Does everyone in this room think that they could give this a go, have a start? Because I don't see why anyone couldn't. It is that simple. I've managed to do it with problems, whilst presenting. Not bad, eh? Right, so there was a question, was there? No. Ah, cool. Look, I'm going to be around the rest of the day. I've got some more interesting, cool demonstrations of AI and deep learning in action out there. Come talk to us. Let's get started. There's no excuse not to do something where you can start to help your customer make better data-driven decisions using this technology. Okay? Awesome. Right, I shall pass you over.
Just to add as well, before we have Ed, so David was talking about inference, so doing things...
There you go. It's all yours, Ed.
So having,
you're welcome, mate.
Having a server in a shop, or in a car showroom, or in a manufacturing plant, you can start getting insights from data immediately without sending them to the data center or sending them to the cloud and latency issues. IBM are releasing, all IBM partners or IBM employees, so IBM are releasing an inference server, so a low-end server offering in December this year. It's GPU accelerated, it's going to be cheap. So keep your eyes peeled for that in December. It's going to be called the IC922. They're really good at cool names. But yes, just if anyone's got any customers who are asking about gaining value from AI on site, in a premises, rather than booking something back to the data center. Right, Ed, your way.
Right. Sorry, just having a slight issue getting my notes up. Give me 1 second. Not quite a live demo, but still seem to have issues. Right, here we go. Okay. So I'm quite conscious of time, so I'll try and keep it around 15 minutes. So if you don't know me, my name is Ed Ffrench. I work for IBM Systems in a power team that's completely dedicated to AI. I've been working on this sign language project recently, and it's using our software, PowerAI Vision. And it started as kind of a play around in my first couple of weeks at IBM, but now it's kind of got a bit more serious now, and it looks like it's a solution that's actually going to be deployed for a client. Right, okay. So before I dive into the sign language application, I'll give you a quick flavor of some I know Beth's already given us a couple, but I'll give you a couple more quick flavor of real-world applications of computer vision across various industries. So this is an example in the US. So a city council is investing in Safer Cities, a Safer Cities initiative. They're using computer vision to automatically monitor traffic intersections. So they're not only doing object detection here, so they can count cars and count people and work out how much traffic there is. But they can do slightly more complex things like detect actions. So here you can see that it detects a near miss when a pedestrian walks past the car. So that can not only let them see how many near misses there are, but if there's an actual accident or another incident that requires emergency response, they can react to it and react to emergencies faster. Another thing they can do with this is they can flag accident-prone intersections, and this can help them to prioritize budgets. So the next use case is for physical asset management. Here we've got a drone flying over a field full of solar panels for thermographic evaluation. So if you stick an infrared camera on a drone, you can actually detect faults with photovoltaic cells. And this can then be flagged to maintenance teams. So here we've got scan avoidance for the retail industry. So theft in UK shops accounts for about £3.3 billion of loss per year. And this prototype detects fraudulent transactions in which an item is actually passed over the bagging area, over and into the bagging area without being scanned. So you might have noticed that more and more at self-checkouts, you get a big screen in front of you which blows up your face in front of you. And this kind of acts as a deterrent. So if you think that you're being watched, you're less likely to steal something. But I actually think that in the next few years, we'll see more and more theft detection models being deployed. So you actually will be being watched. Right, so now let's actually dive into the sign language application. So we started small. I just trained an object detection model to recognize the American Sign Language alphabet. And now we're expanding into something that's a bit more complex. But as an original proof of concept, the ASL alphabet worked really well because it uses single-handed finger spelling. So it works really well for drawing these bounding boxes like you see here. And also the alphabet uses very limited motion, so you can capture it in an individual frame. And this is an absolute dream for building an object detection model. So with any deep learning project, you need a large labeled training data set that your model can learn from. So we kind of scoured the internet online. We looked at places like Kaggle, but all the data sets we found were of really quite poor quality. And our solution was to sort of crowdsource a data set of IBMers. And this involved me kind of charging around the office, and taking photos of people doing the sign language alphabet. Learned a lot of sign language along the way. And we could make sure that people had their hands in the correct position, and that the data set was representative of how a real person would interact with an application. So we ended up with a diverse data set of 22 different people. We had varied lighting, angles, we used different cameras. So we used phones, but we also used webcams as well. So representative of how the real life application would actually work. So we had 4,400 images, and in the software you can grow your data set by augmenting it. So if you add video blur, and you can do things like flick the image, you can grow your data set, which hones your model to a greater level of accuracy. But if you also flip the image, you can get the model to recognize left-handed as well as right-handed people. So we ended up with a data set which was over 30,000 images. So 80% of the time spent on deep learning projects like this is spent just labeling the data set. This is an entire industry almost. You can outsource this to other companies and get them to draw all these bounding boxes for you. But that's why this software includes an auto-labeling feature. So you just go through and label, say, 100 images, and then you train a preliminary model, and you can use that model to go back and auto-label the rest of your entire data set. And it saves you a lot of time instead of having to manually draw all the boxes on 4,000 images. So after you train the model, you get on the right here, you get this quite neat video which shows this neat sort of view which gives you the performance metrics of your model. And from here you can kind of click through and see slightly more advanced tables like confusion matrices. And these can show you where one class is commonly getting mislabeled as another. So we trained an earlier model, and we could see that M and N in the alphabet, which are two very similar signs, were getting mislabeled as each other. So we went back to the original data set and added loads more photos of people doing M and N. So after this, we then developed some Python scripts that produce these tidy sort of subtitled videos like you get here. And as you can see, it makes 0 errors in transcribing the entire alphabet. And we can also do live inferencing as well with API calls to the model. So in terms of actual real-world use case, there's not really that much that can be done with a simple object detection model that only recognizes the alphabet. But we're now collaborating with a security team over in Ireland, and they specialize in gamification. So if any of you have been to the IBM Client Center here in London, you might have seen there's a big arcade game, and it's a security game that team developed. And the idea about getting the security team involved is that if we can gamify the alphabet model, you could use gesture commands to direct yourself through a game. And they're in the process of building that at the moment. But if we put gamification on the back burner for the moment, it's not really what we're here for. When we first started this project, we really wanted to deliver some real benefits to deaf people. And it's really important to get feedback from your user group, because when we were developing this, no one in the team could actually use sign language at all. So we invited this charity, Action on Hearing Loss, which you can see at the top here, in to visit us in London. And they brought an interpreter with them, and it was really interesting. It was something that really blew my mind, and I hadn't really ever thought of it before. Her first language was British Sign Language, because she isn't deaf, but she was born to 2 deaf parents. So she feels more comfortable signing than she does speaking out loud. And she thinks and dreams in sign language, even though she can hear, which was just really amazing, blew my mind. But we did actually get some formal kind of feedback from that session, which is what we were there for, which was that deaf people tend to find situations where they don't understand what's going on a lot more isolating and cumbersome for their day-to-day life than they do the reverse situation where they're struggling to be understood themselves, which wasn't really ideal. It's not what we wanted to hear, because we were working on building a receptive tool which fixed the other problem. But from that session, what we took away is that we really needed to build a tool that allowed for some form of two-way communication. But it's a lot of work to do that. Right, so in terms of the actual final use case for this that we found, there's a cancer centre in the UK that provides medical care to around 1.5 million people. And there was a receptionist there who was answering hundreds and hundreds of calls a day. And they had questions that probably wouldn't justify a doctor's visit, but they're really nonetheless important for the peace of mind of the patient. And the receptionist had so much niche knowledge that she couldn't really be replaced, but they were getting more and more calls, and it was kind of becoming unsustainable for her to answer all these questions. So what they did was they implemented a Watson assistant, a chatbot that could act as this new first point of contact. And I get that this kind of refers back to one of Beth's old points earlier about personalization with AI and how you don't want to replace the personal aspect. And especially in healthcare, you don't want to depersonalize care. But what they actually found was people started asking the chatbot questions that they wouldn't usually ask a person over the phone. So things like, how is my cancer going to affect my sex life? Or even something like, am I going to die? Things that people really worry about but wouldn't ask a receptionist over the phone. So actually what they've realized is that in some ways, but not in all ways, this chatbot can achieve a new standard of care that couldn't be achieved by a person. So the relevance of this in terms of the sign language project is that we wanted to incorporate some kind of sign language capability into the chatbot. And you may kind of think, why would you want to do this? A deaf person can surely just type their questions out. But the actual reality of it, linguistically, sign language isn't the same as spoken English word for word, and there's no written form of sign language. So for someone who's been deaf since birth, learning to read English is like trying to learn to read an entirely foreign language without ever actually learning to read in the first place. So it's really so there's a lot of deaf people, grassroots deaf people, who can't read or write English. So there is a demand there for some kind of translation tool for deaf people. So we want to incorporate two-way sign language into the chatbot. And this would work in, we haven't finished the project yet, but the plan is that the person will sign into their webcam and receive a pre-recorded video response to their questions. And so for this, we're going to need lots and lots of different examples in video form of people signing those top 5 frequently asked questions. And there's no existing data set online, obviously, so this is very work intensive, and it's going to require a lot of work to label it as well. But luckily, PowerAI Vision is a tool for doing all of that. So everything I've shown you up until this point has been an object detection model performing inference or prediction on individual frames. But we're now working with British Sign Language. So with British Sign Language, the signs are a bit more complex and they involve motion. But the newest release of PowerAI Vision includes the ability to train action detection models. So these moving signs can now actually be incorporated. So I had a bit of a go at this. I loaded in 4 minutes of footage of me having a fairly poor attempt at British Sign Language. And I chose 4 keywords or entities from the chatbot's frequently asked questions. So that kind of like a bare minimum, minimal viable product, it would be able to distinguish the top 4 frequently asked questions from each other. And I managed to put together a simple model in just a couple of hours of playing around with it. And that included learning the sign language, filming it, labeling it, and training the model. So this is your Joss from our team. The model's never actually seen him before, ever. But as you can see from the colored bars at the bottom and along the side as well, it actually correctly identifies him doing all 4 signs in a sequence, which I thought was really cool. I'd never really played around with action detection before, but it's really quite sophisticated. Right, okay, I'll wrap up because I know that we all want to go to lunch. So the main thing behind this is that computer vision and the underlying infrastructure behind it has come along really far recently, and this has essentially been driven almost entirely by the race for driverless cars, but it's really quite cool that almost as a byproduct of all of these developments, an AI tool that allows for full sign language translation will probably be achieved in the next couple of years. Thanks very much.